Hey guys, and welcome to a new video in this computer vision tutorial. In this video here, we're going to do stereo vision calibration. So I'm going to show you how we can actually calibrate a stereo vision setup. So first of all, we're going to calibrate both of the cameras individually, and then we're going to combine them to do actual stereo vision calibration later on. We could also do it together, so we're actually calibrating both of our cameras together, but we'll get better results if we do the camera calibration individually, and then we're combining it with the calibration for stereo vision later on in OpenCV. But first of all, we're going to join the Discord server. I'll link to it down in the description here, and you can join the channel, chat with us about computer vision, deep learning, artificial intelligence, and so on. You can also become a member of the channel if you want to support the channel more than you're currently doing by just watching with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So let's now jump into the slide here about camera calibration, because as I already mentioned, we're going to do camera calibration for each of the individual cameras, and then we're going to combine them to our stereo vision setup later on in OpenCV. But first of all, if you want to know more about camera calibration, I've also made videos about just default or standard camera calibration. I also have a lot of different kind of projects here where we're trying to estimate depth to different kind of objects. It could be faces, it could be an object that we're tracking around in the image frame, where we're calculating the depth by using stereo vision after we've calibrated our cameras. So if you're interested in some projects on how we can actually use this stereo vision setup after we've calibrated it, make sure to check those videos out. They're really nice and they're really cool, and it can be used for a lot of different kind of practical examples, applications, and projects. So first of all, here we're going to talk about a brief introduction to camera calibration. So when we're doing camera calibration, we're actually using multiple images. So we want to take multiple images from different kind of angles, and we also need to calibrate our camera around a known object. So in this example here, and what we're using the most in computer vision is a chessboard, as you can see here on the right. So over here to the right, we can actually see this chessboard here. Then we're going to move this around, and in the image frame, we're going to rotate it, translate it around, and also tilt it. So we get multiple images with this chessboard from multiple different kind of angles, and also positions in the image frame. So we can use that to actually calculate our camera matrix, our distortion parameters, our rotation, and the translation vectors that we can then use to actually relate that object to our camera frame that we can use for a lot of different kind of stuff. We'll also get the camera matrix, so we get the focal length and optical center and stuff like that we can use in computer vision as well. Then when we have our distortion parameters, we have our camera matrix and so on, then we can actually just remove the distortion that we have in our images. And when we have removed our distortion, and as we're going to see in this video here as well, then we're going to do rectification as well. So if our cameras in our stereo vision setup is not aligned, then we're going to find corresponding points in both the images, and then we're actually going to rectify them. So we have fixed positions for the C and also the Y direction. So only the X direction, which is the depth in the image, or the X value, or so the width in the image, is actually the only variable that we have when we're calculating different kind of stuff. It could be depth in our image with our stereo vision setup. So we actually want our cameras to be rectified as well. But instead of trying to rectify it with trial and error in person, we can actually just use code and software to do that with our stereo vision setup. So it's really nice and it's really cool. So at the end of the video, we're both going to remove distortion, and we're going to rectify our images as well. So let's now jump straight into the code, where first of all, I'm going to show you how we can actually generate our images for our camera calibration, where I have this iPad that I'm going to move around in the image frame, tilt it a bit, translate it around, and rotate it, as I just talked about on the previous slide here. So first of all, here we're going to have this folder over here to the left. So we have the images in this folder, and then we're also in that folder, we have some subfolders here for the images for the left camera and also for the images for the right cameras. So we're going to use that later on to actually do our camera calibration, but we're going to read in the images from those directories, or those folders here to the left. So first of all, we're just going into this calibration images Python file here. So this is just a script that we're going to run, and then we're going to generate the actual images with our chessboard, and then later on we can just use that to actually do our camera calibration. So I'll put all these different kind of Python scripts in my GitHub, and I'll link to the GitHub down in the description here as well. So make sure to check that out. You can just go take the code, just take the exact same files, create this folder here, this images folder, and then you can actually just run the scripts, generate the images, and then calibrate our cameras. So we can just, basically you can just run these scripts that I'm going to show you now here, and then you will actually be able to calibrate your camera and undistort and rectify your images in your Stereo Vision setup. So first of all, we're going to import OpenCV. Then we're going to open up the two webcams, or I have two webcams in this example here. So we're going to just open up those webcams and I have them stored in this cap and cap2. Then we're going down in the while loop, and we're just running as long as one of the captures here is open. Then we're going to read in an image with this cap.read method here from OpenCV. Then we're reading in each of the individual like frames or images from our webcam. We're storing it in these two variables. Then we just go down here, and then we just check if we're hitting S. Then we're actually saving the images from our webcams into this directory here. So we're just saving the images for the left, like the left images with the chessboard and the right images with the chessboard. We're just going to save them in their corresponding folders up here to the left. And if we hit K, or like if we hit Q here on our keyboard, we'll just terminate the program, because then we have enough images for our Stereo Vision Camera Calibration. So we need around like 3 to 5, maybe 6 images where we actually like rotate and tilt and translate the chessboard around in our image frame. And when we have all of those images, we're just going to hit Q, and it will terminate our program. And then we're just going to release our webcam. So after we have run this script here, we actually like have all of the different kind of like images for our camera calibration. Then we'll go into another script, use those images to do the actual camera calibration. So first of all here, I'm just going to run this Python script in the terminal here. Then we're going to open up both of the webcams, so we can see that we have opened up the left webcam and the right webcam as well. We can see that they're pretty nice aligned here. I tried to align it with this corner up here to the left, but we're going to account for that later on when we're going to do rectification of our images. And we can also see like there's a bit of disparity here to the left. So we have actually like this camera calibration set up here, set up now. So now I'm going to open up the iPad here. We have the chessboard, and now when we hit S on our keyboard, it would actually like save those images here to the folders. So I'm just going to hit S here, and we can see that we have now saved the image. We're going to rotate it a bit here. We're just going to rotate it over here, and then we're going to actually like hit S, and then we set it down here, and we take one more image up here to the top. So now we actually have all of our images here saved. We have 5 images with the chessboard here for both the left camera and also the right camera. And now we're just going to terminate the program here by hitting escape. So now we can go up here to the left. We can see the different kind of images that we have. So in the stereo left folder here, we have the first image here, where we just have the image, the chessboard that we're going to load in and actually like find the corners of our chessboard. And then we're going to use that for camera calibration. So now when we have generated our images for our camera calibration, then we can go into the next script. So this is the Stereo Vision _calibration Python script. So in here in this script, we're going to actually import NumPy, CV, and glob, because we're going to read in all of the images with this glob module, or like this glob framework here. So first of all, we need to find the chessboard corners, and we need to set up our optic points and our image points. So the optic points is actually like the 3D world coordinates for our chessboard that we actually like just took the images off. And then we're going to generate our image points, which is the actual like image point, or like the coordinates of the points of that chessboard in our image. So our object points is our 3D world points, and our image point is our 2D points in our image frame. So first of all, we're going to set up our chessboard size. So we want to find chessboard corners with the size of 9 by 6. So this is just the size of your chessboard that you're calibrating your cameras with. And then we're going to set this frame size here, which is 640 times 480 in this example here. So if you have another resolution or another frame size for your cameras, you can just specify them here. And that's pretty much everything you have to do. So down here, we're just going to set up a termination criteria. So this is just default from the OpenCV documentation. So when we actually like want to terminate our calibration of our cameras, then we're going to prepare our object points. So we actually like have all of these different kind of object points. And make sure to, if you actually like know the size of each of the individual like fills in your chessboard, make sure to take that into account here as well. So in this example, my size here is actually like 2 centimeters. So there's 2 centimeters between all the individual fields where we want to find each of the individual corners in our chessboard. So I need to multiply our object points here by 20. If you have, for example, 1 centimeter between the fields, or like 3 centimeters, then you'll need to specify like 10 or 30 here. So this is just to get like more accurate result when we're going to do our camera calibration, because then we actually like both know our 3D world points, and then we know the exact distance between those different those different kind of corners that we're going to detect in our object points. And we also know the exact distance between them in our image points, which is in the actual like detections that we're going to do, and we're going to show here in the image frame itself. So down here, we're just going to set up some arrays to store the object points and image points for all of the images that we're going to load in, because we're going to load in the images one by one, do the camera calibration, detect different kind of corners in our chessboard, and then we're going to combine them all at the end with these different kind of lists that we're creating here. So we're just going to have this variable images left here and the images right. So we're going to do the exact same thing for both the left image and the right image. So I'm just going to go over it for one image. And as I just said, we're going to do this exact same thing for both images, because we're just calibrating two cameras individually. So we're going to use this glob.glob here to just read in all of the images that we have in this folder. So we have now stored all the images in our stereo left folder in this image left variable. And then we can just have a for loop that is running through all of our images one by one. So we just have one image, and then we just take another image after we have done all the processing and actually like done the camera calibration, where we're finding the object points and our image points for that image. So first of all, we're going to read in the image from the folder, and then we're going to convert the color here from PKR to a grayscale. So we're only operating with one channel instead of 3 channels, and we need to do that to actually like find our chessboard corners, and also just make it faster to do the actual like camera calibration and stuff like that. Then we're going to find the actual chessboard corners with this find chessboard corners method that is built into OpenCV. So this is basically just a function or like a method that you call, and you pass in the grayscale image for both the left camera and the right camera. And you also need to specify the chessboard size in this example here. And then we need to find all the corners in your chessboard, as we're going to see when I'm going to run the program. So all the corners in the chessboard will be stored in this variable here. And we're going to do the exact same thing for the right image, as I already said. Then we can see here, if we have actually like found some chessboard corners in our image frame, then we're just going to append the object points that we created up above to the object points list here. And these are just all the object points that look like this here. And if we know the size between the length between our fields, then we're just multiplying all of these numbers here by the length, which is in this example here 20, because I have 2 centimeters between the fields in my chessboard that I'm calibrating on. So now we're just go down here again, and then we're going to find corner subpixels, so we get a more accurate result when we're finding our actual like chessboard corners. So instead of just finding the chessboard corners, we're going into the subpixels of our image, and then we're finding the corners in the subpixels, so we just get a more accurate estimate of where our actual like corners are in the chessboard. So we're just going to use this OpenCV method here, where we're just specifying our grayscale image for the left camera, and then we also need to pass in the corners that we just found in our chessboard up here above. Then we're just setting up like determination criteria here and stuff like that. And then we find the new corners here for our chessboard, and these corners are the actual like image point. So we're going to append those corners to the image point list up here. And as again, we're going to do this for each of the individual images. So this is just a for loop where we're running through all the images. So this image points list here will store all the image points for all of the images that we load in one by one. We do the exact same thing for the right image. And then we're going to go down and actually like draw the chessboard corners of our image that we just found up here above. So we're just going to specify the image where we actually like want to draw the chessboard corners, and we're going to specify the chessboard size, the corners that we found, and if we actually like successfully found those corners, then we're going to image show this, so we can actually like show or like see that we're actually like detecting, and we're drawing these corners of our chessboard in the image frame. Then we're going to wait for 1 second, and then we're just going to load in the next image, do all the same things here again, and then at the end we have stored all of the things in our image points and in our object points list up above that we're going to do actual camera calibration down here at the bottom. So if we're now going to calibration part, so we both have our optic points and we have our image points, both for the left camera and the right camera. So the optic points would actually be the same because it is just the 3D world coordinates for our object or our chessboard in this example here. So now we can actually do the calibration of our cameras. So we're just going to use this calibrate camera. So this is just a built-in method from OpenCV. We can see over here to the left that we have these different kind of like return values. So we're going to return if we can actually like successfully calibrate our camera. Then we're going to return the camera matrix, the distortion parameters, our rotation vectors, and also the like the translation vector here as well. So in the camera calibration method, we're going to specify the optic points, the image points for the left image, and also the frame size. And then we just have some none here in the two last parameters, which just default here in OpenCV unless you want to use some other different kind of flags when you're calibrating our camera. It could be that you already know the focal length of your camera and stuff like that. So we only want to like get the extrinsic parameters instead of the intrinsic parameters when you're calibrating your camera. So now we're just going to take the shape of our image because we're going to use that to actually like generate a new camera matrix, which is the optimal camera matrix. And we just use the built-in method again from OpenCV. So all of these different kind of things that we're doing is actually like just generating our images, and then we're just passing those images to built-in methods in OpenCV, and it will do everything for us. So we get this get optimal new camera matrix. We pass in the camera matrix that we found in our calibrate camera method up here. We're specifying the distortion parameters and the width and the height of our image frame as well. And then we're just going to do this exact thing here at the end here. So the most important parameters is the camera matrix and the distortion parameters here in this method. We're going to do the exact same thing for the right camera, but then it will return this new camera matrix that we can then use later on to actually like do our stereo vision calibration with both of our images. So if you're going to the documentation here of OpenCV, then we can actually like see how this stereo calibrate here, what it does and what the different kind of parameters it takes. So up here at the top, we can just see like all the different kind of like input parameters that it takes. So down here in Python, we see that we have these object points, image points, and so on that I just went through. And then over here to the right, we can actually like see the return parameters or like the return values that we get from calling this method from OpenCV. Then down here, we get a short description of what this function here does. So it calibrates a stereo camera setup. The function finds intrinsic parameters for each of the two cameras and the extrinsic parameters between the two cameras as well. But in this example here, we have fixed intrinsic, so we won't find the intrinsic parameters for the two cameras. As I mentioned in the start of the video, we can actually like do stereo vision calibration with just calling this method here, and then it will do all of the different kind of like all of the calibration with the stereo vision setup directly by using this function here. So if you scroll down to the bottom, we can see all of these different kind of flags that we can set. So in this example, we're setting this calib fixed intrinsic, and then we can get a short description over here to the right what this flag actually does. So it fixed the camera matrix and the distortion coefficients, or like the distortion parameters. So only the rotation, the translation, essential, and the fundamental matrices are estimated. We can also set some other different kind of flags if we want to like use the intrinsic guess or use extrinsic guesses and stuff like that. And also if you have a fixed focal length, aspect ratio, and so on. So if you want to have some different kind of like or specific things for your applications or for your stereo vision camera calibration setup, then you can go in and check these different kind of flags and see if you want to set some of these flags before you're calling this method in OpenCV. So let's now jump into the code here again and see the return values that we get from this stereo calibrate method from OpenCV. So we get both the neo camera matrix, the distortion parameters, and so on, which is the same as we already have been through because we have this calib fixed intrinsic parameters. So the only things that we get here by using this function is the rotation vectors, the translation vectors, the essential matrix, and the fundamental matrix. And these are just matrices to describe like how we can relate one camera to the other. So we can use the essential matrix and the fundamental matrix to do a lot of other different kind of applications where we can use like epipolar geometry to find like lines or like find different kind of points that we want to estimate the depth to. So it's just like how we can relate one point to the other, like one point in one camera to another point in the other camera, like the exact same point in the other camera. So we can use the essential and the fundamental matrix for that. So now we can go down here and do the actual like rectification and the undistortion of our image. So we're just going to set a scale here for rectification. So we just want to set that equal to 1. Then we're going to use this stereo rectify, where we just pass in all the parameters that we got from this camera calibration function up above. We're just going to put all these different kind of like default parameters into this function, and what we get out is the actual like rectification for a left camera and rectification for a right camera. So we're actually like rectifying, or we're aligning the y-axis and the z-axis in our image, so we only have the disparity that we can then use, which is the variable in our image frame. We also get our projection matrix for the left image and the projection matrix for the right image, where you get the Q matrix here as well. So then we can use all these different kind of informations, all the information to do this init undistort rectify map. So this will just be a map on how we can actually like undistort and rectify our image that we can then use later on. So we're just going to store these parameters, and we pass in the new camera matrix, the distortion parameters, and also the projection matrix. And then we're just going to specify some default parameters here at the end of the function. So we'll get a stereo map for a left image, and we'll also get a stereo map for a right image. And this is just like how we can describe how we want to actually undistort and rectify our images when we're going to use this map later on. So now we have actually like calibrated our Stereo Vision camera set up here. We can then save our parameters. We're going to open up a file here with OpenCV. So we're just going to have this stereo map.xml file, and then we're just going to write this stereo map L here for the X direction and the Y direction. And then we're just going to write that out to the file. We can then load it in later in our application or in our own project. And then we can just undistort our image with all of these different kind of like stereo maps for both the left image and the right image. So if we now run this Stereo Vision calibration script here, we will actually like load in each of the individual images that we can see here. We are detecting all of the corners in our chessboard, as we can see. Then we're actually like setting up our object points, as we can see down here in the output. So we can see that we're multiplying by 20, like all of the different kind of indexes. We're multiplying that by 20, as already mentioned. And then at the end, we're just saving the parameters. So if we're going to our folder here with our program, then we can see we now have this stereo map.xml. It had done all of the calibration, and we have stored all of the maps here on how we can describe our rectification and undistortion of our images, both for the left image and the right image. So we have all of these different kind of like values here that we're loading in the next Python script in our program. So now we have done the calibration. We have all of these parameters for all the maps, and then we can then just use that in another application. So we only need to do this once, and then we can just load in these parameters in our projects over and over again. So now when we have calibrated our cameras, we can now actually go into our project or like application that we're going to do. So I'll just go into the Stereo Vision Python file here, where we're actually like going to run our project. And in this project, we're just going to like read in the parameters that we just calculated or like calibrated. And then we're going to use those parameters to undistort and rectify our image. And then we can just use it in our application to do like stereo vision, calculate depth of different kind of objects, some different kind of object detections, and so on. So first of all, we're just going to open up the file now, and then we're just going to read in the stereo map for both the X direction and the Y direction. So we can then use that later on to actually like undistort and rectify our image. Again, we're just going to open up the capture here in the right image and in the left image. So we can actually just read in the images from our webcam later on. We're going to have the while loop running while our cameras are open. Then we're going to read in each of the individual frames from our camera, stored in these two variables, frame right and the frame left. Then to actually like undistort and rectify our images with the maps that we just created in the previous Python script. Then we're going to have this frame right here, which is equal to cv2.remap. So we're going to use this method remap. We're going to pass in the right image from the right camera. This stereo map for the right image as well that we calculated and calibrated, and we're going to specify the X direction and the Y direction. And then again, we just have some default parameters that we just need to specify here at the end. And if you want to know some specific thing for your applications, or you want to like change these parameters, make sure to go into the OpenCV documentation and read about like what all of these different kind of things here does. So we're going to remap both the right image and also the left image, and we're going to do the exact same thing. The only thing that we're changing is the stereo map here for the left image and the right image up here above. And we're also the input image here that we actually want to undistort and rectify. So now we can just show the frames here that we have calibrated. So first of all, we have calibrated our cameras, we stored the parameters, then we open up a script with our project or application. We have now rectified and undistorted our images, and now we can just show them. We could have done some different kind of other different kind of projects as we have already done, where we're, for example, calculating the depth to an object that we're tracking around in the image frame. We can do some other different kind of operations, algorithms, projects, and so on. So we're just going to show the images here that we have undistorted and rectified. And if we hit Q on our keyboard, we're just going to like get off this while loop. We're breaking off the while loop. We're releasing our webcams, both the right and the left webcam, and then we're just destroying all the windows from OpenCV here. So let's now actually like run this application or like this Python script here, which is the Stereo Vision's vision here. And then we can see that we have now actually like opened up the two image frames here again. We're undistorting our images, and we're also rectifying, so we can see that we get some cut here down in the bottom, because we're actually like rectifying our images so they are aligned in the X direction, or like in the Z direction and the Y direction. And then like it looks a bit funny here when we're actually like doing this rectification. We could play around with our camera, try to like adjust it a bit in person as well, do some trial and error with that. But this is the exact result here. We have rectified them so both of our axes is actually like fixed. And then we can now use this here. We have undistorted our image, we have rectified it, then we can use it for our Stereo Vision application and project. So that's pretty much it for this video here, guys. We've been over like how we can calibrate our cameras individually, how we can combine them, do the Stereo Vision camera calibration, save all of the different kind of parameters for our Stereo Vision maps to do the actual like rectification and undistortion, as we can see in these images. Then we save those parameters. We went into our own project or application. We imported those parameters, and then we can just call a remap function or like remap method from OpenCV to do the actual like undistortion and rectification of our images. And then we get this result here and can use that in our own application with our Stereo Vision setup. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video. And also like this video here if you like the content and you want more in the future. I'm currently also doing this computer vision tutorial as you're already watching, but if you want to know more details about how we can use, for example, like neural networks with OpenCV, how we can do basic operations on images, it could be like edge detection, coordinate detections, and so on, and also just object detections. Make sure to check those videos out I have in that tutorial. I'll link to the computer vision tutorial up here. It's really nice. There's already like a lot of videos in that, and a lot of different kind of like information videos, theory and practical examples and projects as well. So thank you guys for watching it once again, and I'll see you in the next video. Bye for now.